Let's look at graphing a variety of functions. The first function we're going to graph is the squaring function. Y equals f of x equals x squared. So negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And we need to graph these ordered pairs. Negative 3, 2, 4, 6, 8, 9 would be approximately up here. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So this shape is actually called a parabola. See how well I can do at drawing this today. Okay, that's a parabola. The domain is all real numbers from negative infinity to infinity. The range, starting from the bottom, the first place I run into is 0. That is counted, so that's a bracket, and it goes to infinity. The squaring function is really pretty much the opposite of that. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is not a whole number. It's the square root of 2. It's approximately 1.414. The square root of 4 is 2, and the square root of 9 is 3. You might just see how selectively I did my x values. 0, 0, 1, 1, 2, 1.414, 4, 2, 2, 4, 6, 8, 9, 3 would be approximately here. Now you might notice this is only part. Remember, we defined the domain is the ones that will give us real numbers. If I went to domain of negative x, that would not be a real number. So it's not in the domain of the square root function. So the domain here starts at 0 with a bracket and goes to infinity, and the range does the same from 0 to infinity. Now this is a parabola opening to the right. It's that same shape, but it opens to the right. Notice I started with the y values since x equals y squared. So 9, 4, 1, 0, 1, 4, 9, those same numbers we had before. 9, negative 3 would be approximately here. 4, negative 2, 1, negative 1, 0, 0, 1, 1, 4, 2, and 9, 3. So this is a parabola shape again that opens to the right. As it said, this is not a function. It does not pass the vertical line test. The domain, the x values that work, since even if it's not a function, it still has a domain. All relations have domains. The domain is from 0 to infinity, and the range is all real numbers from negative infinity to infinity. Now the cubing function. So y equals x cubed, negative 3 cubed is negative 27. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. Now, the 27s are not going to fit on my graph. Let's do negative 2. Negative 8 would be approximately here. Negative 1, 0, 0, 1, 1, and 2, 8. Now, please do not draw this straight across here. This has a little bit of a curve as it comes up here. A curve, and it kind of curves. Kind of a little wave, more like that. So this is the cube function. The domain, x values are all real numbers, and so is the range, also all real numbers. Now this is the cube root function. It was easiest, my x values I picked selectively, so the cube root of negative 27 is negative 3. The cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. Cube root of 0. Cube root of 1. Cube root of 8. Cube root of 27. Of course, once again, my 27s are not going to fit on my graph. Negative 8, negative 2 will be down here. Negative 1, 0, 0, 1, 1, and 8, 2. Now this really is the same shape as the last one, except it's just turned some. It's a little bit of a different angle. And it becomes a shape like this. Okay. The domain, all real numbers, and the range is all real numbers. Now we need to talk a little bit about semicircles. You can imagine a circle is not a function, but let's talk about semicircles. We're going to solve this equation for y. So I'll go y squared equals r squared minus x squared, and then I'll take the square root of both sides, and y will equal plus or minus the square root of r squared minus x squared. This is the whole circle, since it's plus or minus. We can have a semicircle if we only do the top, so the positive part of r squared minus x squared will be the top semicircle, and the negative part will be the bottom semicircle. This will give me the bottom. And we need to recognize those shapes and recognize that equation. So this we have, here's my r squared minus x squared. We should recognize this. If y equals the square root of a square minus x squared, or this doesn't even have to be square, we should recognize that it's a semicircle. Here, since it's r squared, the radius is 4, and this is centered at the origin, since it was just x squared y squared. Centered at the origin has a radius of 4. So 4, this is the positive one, so it will be the top half of the semicircle. The domain or the x values range from negative 4 to 4. Those are brackets since those points work. The range from here to here is from 0 to 4. So that was the top half of a semicircle. Now, since this is a negative, that means it's the bottom half of the semicircle. And the radius is square root of 25, 5. So the center is again at the origin. We have a radius of 5. So go 5 each direction. I use the ones that are right on the axes so I can find them. And I want to make this look somewhat like a semicircle. Try to do your best there. And the domain here, the x values at work, go from negative 5 to 5. And the y values, the range, start at negative 5 and go to 0. Now remember, it's not this 0 we're going to, it's this one and this one that we're going to.